Hi everyone, for this question they ask us use Newton-Raphson method means Sn plus 1 equals to Sn minus Fxn over F prime Xn to estimate the intersection point. So it's a coordinate that you need to find. So they want intersection point for the first curve y equals to cos x plus pi over 2 and the other curve x minus pi with the initial value of pi and then correct the answer to 3 decimal place. So to find intersection point, we need to solve these two simultaneous equations. We substitute and we let it to be 0 so that we can form out function. So we move the term to the left hand side and this will be our function cos, where angle here is x plus pi over 2 minus x plus pi. So what we need to do next is find out our differential function. Differentiate cos. It can give us negative sign. But don't forget differentiate your angle. So differentiation, differentiate trigo, differentiate angle. So multiply differentiate angle. Angle is x plus pi over 2. Or we simplify it is x over 2 plus pi over 2. So when we differentiate this, it will leave us coefficient of 1 over 2. And when we differentiate constant, it will give us 0. So 1 over 2 plus 0. Then when we differentiate negative x, it gives us negative 1. When we differentiate constant pi, it gives us 0. So after differentiation, our formula will be 1 over 2 sine angle x plus pi over 2 minus 1. Then we can start using our Newton-Raphson method with x naught, initial value, which is pi. We're going to find out what is our x. So we're going to solve this non-equation to get the x, and we need to get until the intersection point. Means after that, you need to find your y. So to get x1 means we substitute pi into the formula. So write this step fully. So function here is cos, x is pi, differential function, negative 1 over 2 sine, x is pi, minus 1. And we use calculator to formulate this expression, alpha x minus function cos alpha x over 2 x plus pi. Then minus alpha x plus pi. Denominator differential function, negative 1 over 2 sine alpha x plus pi 2 minus 1. Make sure our mode here is radian because we are using pi here, so we need to shift mode, change the angle unit to be radian. Then only we start calculate. So our first answer will be 2.19. So how many decimal we need to show in working? when it said rounding off to 3 decimal, we maximum can plus one more or two more. If you're having too many of decimal in calculation, it will affect our repetition. So therefore, we only accept maximum extra one or two decimal. So if you want 3 decimal here, 192, then extra 2, 53. Then for second one, you substitute this value into the function and differential function. Zero, zero, 9, so we round off become 0, 1. Then continue until we get the repeat value. So repeated, therefore we can conclude up x is 2.241. But then this one is not the final answer because they asked us to find out the intersection point, which means we still need to substitute x 2.214 into either one equation. So I will substitute into 2 to find y coordinate. Zero, 5, so 0, 1. So therefore, lastly, only we can get the intersection point is 2.241 and then negative 0.901. Now we're going to see what is important here. First of all, when we want to use Newton-Raphson method, we need to find out our function, and the first method is form out our differential function. Once your differential function is correct, then only we will continue to see your Newton-Raphson method. If your differential function is wrong, then everything will be getting wrong. So you will not having any mark after that. So we consider for the first derivative function correct, then we continue to see the next concept is how you substitute into the Newton-Raphson formula and to get until the first value of x, then continue finding value of y and put it in intersection point form, where in the bracket x, comma y. So that's all for this.